The weight loss industry generates $90 billion a year in the United States alone. Diet pills, meal replacements, membership programs, surgical interventions. The entire machine built on a single premise: eat less, move more, and the math will work in your favor. And yet rates of metabolic disease, obesity, type 2 diabetes, fatty liver have climbed every decade since we started measuring them. Something is missing from the model. Researchers at the University of California, Berkeley published findings in 2024 that pointed to something the industry has consistently underweighted. Not calories, not macronutrients, not exercise frequency, sleep architecture. Specifically, what happens to your fat metabolism during the deepest phase of your sleep cycle. A phase most people spend far less time in than their bodies require, and a phase that turns out to be controlled, in part, by a system we only began mapping in the last decade. There is a switch. You have it. It fires while you're unconscious, and most of the things modern life does to your sleep schedule are, systematically, turning it off. Wait, that's real. Let's start with the science of fat, because it's more specific than most people realize. Your body stores fat in two fundamentally different types of tissue. White adipose tissue, WEAT, is the storage tissue. The fat around your abdomen, your thighs, your organs. This is where excess energy gets parked. Brown adipose tissue, BAT, is different. It is metabolically active. It doesn't store energy. It burns it. It contains a high density of mitochondria, the cellular structures that convert nutrients to energy, and it is thermogenic, meaning it generates heat as part of its function. BAT burns calories at rest. It is, in the most literal sense, metabolically active fat that makes you burn other fat. Infants have large deposits of it. They need it to regulate body temperature. Adults have much less, primarily located around the collarbones, along the spine, and around the kidneys. For decades, researchers thought adult BAT was vestigial, a biological remnant with minimal functional significance. That view was wrong. In 2009, 3 independent research groups published simultaneous papers in the New England Journal of Medicine confirming that adult BAT is metabolically active and that its activity level varies significantly between individuals. People with high BAT activity burn meaningfully more calories at rest. They have lower rates of obesity and metabolic disease. The question immediately became, what regulates BAT activity? The answer, developed over the next 15 years, points substantially to slow-wave sleep. Slow-wave sleep, also called Stage 3 NREM sleep, or deep sleep, is the deepest phase of your sleep cycle. Your brain produces slow, high-amplitude delta waves. This is the phase associated with physical restoration, immune function, and growth hormone release. It is also when a cascade of hormonal signals associated with BAT activation is most pronounced. During slow-wave sleep, the body's core temperature drops. Norepinephrine, the primary activator of brown fat thermogenesis, is released. The parasympathetic nervous system, which governs restorative processes, is dominant. This is the physiological context in which BAT does its primary work. The 2024 Berkeley study, published in the journal Cell Metabolism, added a specific molecular layer to this picture. The research team, led by Professor Daniela Kaufer's lab, identified a neuropeptide called Galanin as a key signaling molecule in the relationship between deep sleep and fat metabolism. Galanin is produced in the hypothalamus. During slow-wave sleep, galanin release increases significantly, and galanin has been shown to directly activate brown adipose tissue, specifically by upregulating the expression of a protein called UCP1, or uncoupling protein 1, which is the molecular mechanism by which brown fat generates heat. When the researchers suppressed galanin signaling in mice during their rest periods, BAT thermogenesis dropped. The mice accumulated more white adipose tissue. Their resting metabolic rate declined. When galanin signaling was restored, the effects partially reversed. The researchers called this pathway the Sleep-Metabolic Axis, a direct hormonal link between the depth of your sleep and your body's capacity to passively burn stored energy. Here is the disruption problem. Slow-wave sleep is the phase most sensitive to sleep fragmentation. Interruptions that don't fully wake you but pull you out of deep sleep back into lighter stages. This includes alcohol, which suppresses slow-wave sleep in the second half of the night. Blue-spectrum artificial light in the hours before bed, which delays melatonin onset and shortens the slow-wave window. inconsistent sleep timing, which disrupts the circadian synchronization that slow-wave sleep depends on, and sleep apnea, which fragments sleep architecture through repeated micro-arousals. According to the CDC's National Health Interview Survey, approximately 35% of American adults sleep fewer than 7 hours per night. A separate analysis of polysomnography data, actual sleep architecture measurements, suggests that average slow-wave sleep duration in American adults has declined over the past 3 decades. We are collectively spending less time in the phase of sleep that activates the biological system responsible for passive fat metabolism. The dietary interventions and the exercise interventions are operating in a context where the foundational metabolic process has been systematically suppressed. Now, let me be precise about what this research does and does not claim. It does not claim that sleep is a weight loss solution. It does not suggest that sleeping more will cause fat loss independent of dietary intake. The Galanin and BAT pathway is one component of a complex metabolic system. Its dysregulation contributes to metabolic disadvantage. Its restoration improves baseline function. What it does establish is a mechanism. There is a specific hormonal pathway now identified at the molecular level that connects sleep depth to fat metabolism. This is not a wellness claim. It is a peer-reviewed finding with a molecular target. The practical implications are direct. Alcohol before bed, even moderate amounts, measurably reduces slow-wave sleep duration. This is pharmacologically documented. The mechanism is that alcohol is a GABA-A receptor agonist. While it accelerates sleep onset, it suppresses delta wave activity in the second half of the night, which is when the majority of slow-wave sleep normally occurs.
Drinking water with caffeine or alcohol before bed. Caffeine blocks adenosine, your natural sleep signal, for up to 8 hours. Alcohol fragments REM sleep dramatically. Combining either with water before bed compounds the damage. Avoid both for at least 4 hours before sleep. Get these 3 right, and most
bright light exposure in the 2 hours before sleep. Specifically, the blue spectrum from LED screens and overhead lighting suppresses melatonin onset, shortens the total sleep period, and reduces the depth of early slow-wave cycles. Inconsistent sleep timing, going to bed and waking at different times across the week, disrupts the circadian regulation of growth hormone and cortisol, which are key modulators of the slow-wave sleep window. None of these are new pieces of information. What the Berkeley findings add is the specific why. These behaviors suppress the Galanin UCP1 pathway. They turn off the biological switch that enables passive fat metabolism during sleep. The pharmaceutical implication is significant. Galanin receptor agonists are now being actively investigated as a drug target for metabolic syndrome. Clinical trials are in early stages. If the pathway holds, there is potential for a drug that partially replicates the metabolic function of deep sleep in people whose sleep architecture is chronically impaired. Here's why this story matters beyond its specific findings. We have spent decades trying to solve metabolic disease at the conscious level. Choices, behavior, diet, exercise, and these things matter. They genuinely do. But the body's metabolic machinery is largely not under conscious control. It runs on circadian rhythms, on hormonal cascades, on sleep architecture, on systems that do their work while you're unconscious, and whose mechanisms we are only now beginning to map at molecular resolution. The Galanin discovery is one piece of that map. It is specific. It is replicable, and it points toward an intervention target, a switch that operates completely independently of how many calories you ate for lunch. That's a different kind of leverage than the weight loss industry has historically sold you. Not willpower, not restriction. A biological mechanism that, under the right conditions, runs automatically. The condition is sleep. Real sleep. The kind that takes time to reach. The kind that modern schedules and modern screens and modern drinking habits have been quietly compressing for 30 years. There is a version of metabolism that runs at night without your input, if you give it the conditions it needs. The question is whether the information is enough to change what happens between now and when you go to sleep tonight. Subscribe to Wait, That's Real? New deep dives every Wednesday.